Hello, Algebra 1. Welcome to LSPF2. Again, that's linear systems and piecewise functions. Second target, solving linear systems by substitution. Now, what exactly does that mean? What does substitution mean? Substitution is exactly what you think it is. You take something and put it in place of something else. You substitute something in for something else. So what does that look like mathematically? And I think that's a great question. I'm going to skip this first page and go right to the main part. Solving linear systems, we've already done graphing, right? You graph two lines and see where they cross. We know that that's an okay way to do it, but it's not an exact way all the time. Like, yeah, most of the things that we do, okay, they cross exactly at, 2,3, and, it looks pretty good. But what if the answer isn't maybe as exact? We need to have some algebraic methods to do that. And this is one of them. And this is probably one of my favorite things ever in terms of math here. So let's go and talk about this. Solving consistent independent linear systems by substitution. In other words, let's talk about how two lines can interact, right? I could have two lines that cross at one point. I could have two lines that are parallel and don't have any intersection points. I could also have two lines that are, well, actually the same line and have an infinite number of solutions. What I want to start with here is what happens when we have one solution? What does it look like? No matter how many solutions you have, the steps will be the same. And the steps are this. Number one, solve one of the equations for one of its variables. So right here, I'm going to have to just right off the bat, star this, do what you got to do. These are your steps. Solve one variable, one of the equations for one of its variables. And I'm going to add this part here. Make it easy on yourself. Make it easy on yourself. And we're going to take a look and see what that looks like here shortly. Number two, substitute the expression from step one into the other equation and solve for the other variable. And step three, substitute the value from step two into either the original equation into either original equation and solve to find the value of the other variable. In other words, when you've got two lines and they cross somewhere, they cross at the same x and the same y. In other words, there's an x and y coordinate point that's a solution to both lines. In other words, the x's and y's are equal at some point. Let's see what this looks like here. Number one, the example one says, solve each system of linear equations by substitution. I have 3x plus y equals -3 and -2x plus y equals 7. Now, what I mean by step one is solve one of the equations for one of its variables and then make it easy on yourself is right here. If I look at 3x plus y equals -3, y is already without a coefficient. You won't have to do any division. In other words, it's a one-step equation to get y by itself. If I subtract 3x from both sides, I have y equals -3x minus 3. And here is the beauty, okay? That's step one. Step two is substitute that anywhere in the second equation that you see y. Anywhere in the second equation where you see y, you're going to substitute instead -3x minus 3. Now, it's important that you start by putting it in parentheses first. And we're going to talk about why once we get to some of those examples. So what we're going to do here is, just like they did, that second equation, anywhere I see y, that -2x plus y equals 7, anywhere I see y, I'm going to replace it with -3x minus 3. So -2x plus, and then in parentheses, -3x minus 3 equals 7. So now we've done step two. We've substituted that in. Well, that's kind of nice now because all we have is one variable. If we have one variable, we can solve for that variable and find the value. And if I look here, I'm just distributing a +1 through that binomial, that two-term parenthesis thing. So in other words, it doesn't change it. I have -2x plus -3x or -3x minus 3 equals 7. Well, knowing what I can do, I can combine the terms with x. This is -5x minus 3 equals 7. And now I've just got your run-of-the-mill two-step equation. Add 3 to both sides. I have negative 5x equals 10. Divide both sides by negative 5. X equals negative 2. Yay, x equals negative 2. Just like they got. X equals negative 2. Fantastic, we're done. No, not really. Not really. Because if two lines intersect, they don't just intersect at an x value. They intersect at an x and y value. I need to take that x value that I just found and plug it back into either equation, because you're going to get the same thing because they're at the same point, and find a y value. I'm going to tell you to plug it back into the one that you solved and you isolated. Why not? Why not solve it? I mean, you've already got y equals. So just plug your x in and find y equals negative 3x minus 3. I'm going to rewrite it. Y equals negative 3x minus 3. If I plug that negative 2 in, y equals negative 3 times negative 2 minus 3. So negative 2 times negative 3 is 6. 6 minus 3 is 3. Y equals 3. These two lines cross when x is negative 2 and y is 3. In other words, you write the solution as an ordered pair, negative 2 comma 3. Now it says check by graphing. I disagree with checking by graphing. It's not exact. Plug them back in to both equations and check them. Plug negative 3 in for y. I'm sorry, plug negative 2 in for x and 3 in for y and check. Yes, it will work out. Oh, it's one of my favorite things in the world. Okay, absolute one of my favorite things in the world. Let's do one more example together. Let's do one more example together. Okay. I have x minus 3y equals 9 and x plus 4y equals 2. Remember step one. Step one says to solve one equation for one variable and make it easy on yourself. I'm just going to take that top equation. I don't have a coefficient on x. I'm just going to solve for x. I can do that. If I'm solving for x, I'd add 3y to both sides. X equals 3y plus 9. That's step one. We've solved one equation for one variable. The second step is anywhere you see x in the other equation, you're going to substitute 3y plus 9. In other words, 3y plus 9 in parentheses plus 4y equals 2. Well, there's nothing multiplying the parentheses, so I can not drop them, but essentially distribute a 1 through and get 3y plus 9 plus 4y equals 2. Combine like terms, 3y and 4y you can combine to 7y plus 9 equals 2. There's our two-step equation. Subtract 9 from both sides. 7y equals negative 7. Divide both sides by 7. Y equals negative 1. Y equals negative 1. Just like we did in the first one, though, we're not done. Two lines can't intersect just at a y value. We also got to find an x value. It'd be really nice if we had an equation that said x equals something. We do. X equals 3y plus 9. So if x equals 3y plus 9, and y is negative 1, x equals 3 times negative 1 plus 9. Well, 3 times negative 1 is negative 3, and negative 3 plus 9 is 6. X is 6. These two lines intersect. They do intersect, and they intersect at the point 6, comma, negative 1. So 6, negative 1 is the solution. Is the solution. We're going to talk about the graphing thing. Plug those in to both equations. I don't like the whole checking by graphing thing. I'm not impressed with that. Plug them back in. Plug negative 1 in for y, plug 6 in for x, and you will get exactly the correct answers. You'll get true equations. Okay. Guess what? Your turn. Follow those steps that you started. Try them out. See what you can do. Go. All right, so they started you off with a nice one. I like this one. Solve the system of linear equations by substitution. Again, step one, take one equation, solve it for one variable. The top line, 3x plus y equals 14. I think that one's more efficient. I think it's most efficient to solve for y because y is already without a coefficient, or the coefficient is 1. All I have to do to solve for y is subtract 3x from both sides. If I do that, I end up with negative 3x plus 14, and this is where you got to be careful. This is why I said use the parentheses, because it's negative 6 times all of that. It's negative 6 times, in parentheses, negative 3x plus 14. You have to distribute the negative 6 to the negative 3x and to the positive 14. You end up with x equals 3 after you solve, plug back in, solve for y, and y equals 5. All right. Let's do this. What happens? What does it look like when you have no solutions? Okay, what does it look like when you have no solutions? The first equation, x plus y equals 4, and the second one's negative x minus y equals 6. I'm going to take that first one. I'm going to solve it for y. I don't like what they've done. That's fine. I mean, it's fine. I'm going to subtract x from both sides. Y equals negative x plus 4. It didn't matter. I could have solved for x. Doesn't matter. Anywhere I see y in the second equation, instead, I'm going to put negative x minus 4. And if I do that, I have negative x minus, and in this case, remember, this is the parentheses, negative x plus 4 equals 6. Remember, I substituted that in. Now this is another one of those cases where it's important. I have to distribute a negative 1 to the negative x and the positive 4. Negative x, well, plus x minus 4 equals 6. Well, this is about to get real interesting here, because negative x plus x is 0. I'm left with negative 4 equals 6. Does negative 4 equal 6? No. We ended up with a false equivalency, something that's not equal to another. Since negative 4 cannot be negative 4 cannot be 6, we put that line to make it not equal. And we say this equation, it's a false statement. Since it's false, it's no solution. And if you graph them, you get two parallel lines. So since it's false, you've got no solutions. Let's do another one real quick. Part B, it says solve one of the equations for one variable. I like that top one. It's got an x by itself. Solve for x. X equals 3y plus 6. Anywhere I see x in the second equation, I'm going to instead replace it with 3y plus 6. And if I do that, I have 4 times parentheses 3y plus 6 minus 12y equals 24. If I distribute through, I have 12y plus 24 equals 24. Oh, sorry, I forgot the minus 12y part. Minus 12y equals 24. Well, if I simplify here, what's 12y minus 12y? Well, that's 0. And I have 24 equals 24. Well, that's interesting. That's different from the first one we did. That's a true statement. Wait a second. These are the same lines. These are the same lines. Huh. These are the same lines. 24 equals 24. So it's not like we're solving for something. We end up with a true equation. The resulting equation is true. So the system has an infinite number of solutions. Why? Because they're the same line. They're the same lines. And if you graphed them or put them in a Desmos, they'd be the same lines. Okay? That's how you get the same things that we did with graphing. With intersecting one time, with parallel lines, and with the same line. Well, you know what time it is. You know what time it is. It's your turn. Give these two a shot. come back and check your work. All right, go ahead and check your work on numbers 7 and 8. Number 7, I think that second equation is more efficient to find a variable to solve for. So I added 7y to both sides. I substituted 7y plus 14, and where I saw x in the first equation, I solved, and turns out that negative 28 equals negative 28. Well, that's because this is a true equation. It's a true statement. They are the same line. I have an infinite number of solutions. In number 8, I solved the top one for y. I have y equals 3x plus 12. Then I substituted anywhere I saw y in the second equation with 3x plus 12. I end up with negative 24 equals 18, but it turns out, you'll be surprised, negative 24 does not equal 18. And since you end up with a false statement, these are parallel lines with no solutions. There's no places where they are the same. Okay, let's go ahead and take a look at this thing, all right? We're gonna look at solving models by substitution. And what we're gonna have is we've got fitness center A and fitness center B. What we're gonna end up with is how to describe the solutions. That's the big key here, okay? We've got fitness center A, we've got T, okay, this is kind of nice. We've got T is total cost and M is months. So it's kind of nice. We've already got our variables here. And how many months will both fitness centers cost the same? And what will the cost be? In other words, there's kind of like a part A and a part B here. We got to find both of those. No, I shouldn't use A and B, right? How many months? This is our M for months. And what will the cost be? This is our T. So here I've got my two equations. I have T equals 60 plus 35M and T equals 45M. Well, this is kind of nice. They're already solved for a variable. If I take this first one right here, and anywhere I see T in the second equation, I'll just put 60 plus 35M. 60 plus 35M equals 45M. Right? Same thing that they got going right here, right? If I subtract 35M from both sides, 60 equals 10M. Divide both by 6 and, I'm sorry, divide both by 10 and M equals 6, or 6 equals M. M was what? Months. So we know in 6 months they're going to cost the same. Now we got to figure out what's that cost going to be. And here's the thing, we just got to plug it into either equation. It's going to come out the same. If we put 6 back in for M, 45 times 6, because we'll use that second equation, T equals 45M. 45 times 6 is 270. We have 6, 270. In other words, after 6 months, they will cost the same, and that value is $270. Right there. Right there. Let's look at B. It says a high-speed internet provider, A, has a setup fee of $100 and costs $65 per month and can be expressed using this one. Oh, there we go. B has a setup fee of $30 and costs $70 per month, the second equation. So we're trying to figure out how many months will they both cost the same and what will the cost be, knowing T is the total amount and M is the number of months. Well, they're already solved for a variable. I'll take this. Anywhere I see T in the second equation, I'm going to replace it with 100 plus 65M. So I have 100 plus 65M equals 30 plus 70M. Well, I need to solve for the variable. I need to get the variable on one side and the constants on the other. So what I'm going to do is I'm going to subtract 65M from both sides. And I have 30 plus 5M on the other side. If I subtract 30 from both sides, I have 70 equals 5M. Divide both by 5 to get M by itself. And 70 divided by 5 is 14. So we know that 14 months. So we've got 14 months. We got to figure out what the cost is going to be. What's the cost going to be in 14 months? Okay, so let's go ahead. Let's continue this. We're going to substitute 14 for M. Okay, we have 70 times 14. Let's see, 980, 30 plus 980. So after 14 months, it's going to cost $1,110. Both internet providers will cost $1,110 after 14 months. Oh, you know what time it is. You know what time it is. It's your turn. Read it, solve it, and interpret it. This is like your 3 style questions. Go. All right, I'm going to highlight that last question. It should have been 1,010. I got a little excited. I added an extra 100 in there. 30 plus 980 is 1,010. Is 1,010, not 1,110. Got a little excited. So in the your turn, we've got this boat. We got one boat travels at a rate of 18 kilometers per hour from its port. A second boat is 34 kilometers behind the first boat when it starts traveling in the same direction at a rate of 22 kilometers per hour to the same port. Let D represent the distance the boats are from the port in kilometers. So that's nice. We got that one. T represents the amount of time. And what we do is we find this. What I did is I just took anywhere I saw D in the second equation, I put 18T plus 34. And then I solved for T and I get 8.5, which means 8.5 hours, 8.5 hours. Then I plugged 8.5 in and found, it didn't matter which one I plugged it into, I ended up with 187 kilometers. In other words, it will take 8.5 hours for the second boat to catch the first boat, and they will be 187 kilometers from port. Not sure. There we go. Now we've got a second method. For solving linear systems. Take care. Have a fantastic day. You guys are awesome.